All right, so let's talk about the isosceles triangle theorems. Well, first of all, what is an isosceles triangle? First of all, an isosceles triangle is a triangle with two congruent sides. So there, that is an isosceles triangle. Because I put two tick marks on the sides, meaning that those sides are the same. So what we can do is, if that is what we're given, we can say if we have an isosceles triangle, so if we have an iso, then something happens. Then we know that these angles are going to be congruent. So let's just say that these angles are congruent for now. So let's talk about some names in the isosceles triangle. In the isosceles triangle, the two sides that are congruent are called the legs, and the other side is called the base. Now it sort of follows that these two angles, the two purple ones, if you can tell that's purple, these two purple angles are going to be called the base angles. And this one up at the top, I don't know why, but it's called the vertex angle. They just called it that. They being some math people. This is the vertex angle. So we have the vertex angle and the two base angles, and we have the two legs and the base of an isosceles triangle. Now, even if your isosceles triangle looked like this and it was upside down, the odd side out is still called the base, and the angle between the two legs is still called the vertex angle. So it doesn't matter orientation. It only matters that the odd leg out is called the base, and the odd angle out is called the vertex, and then you have two legs and the base angles. Great. Now, what happens if we take this idea and we flip it? We get that if you have two angles that are congruent, let's say two angles that are congruent in a triangle, then what do you get? So all I know is that if I have some triangle and all I know is that these angles are congruent, well, what do I know? Well, if those angles are congruent, then it is an isosceles triangle. Meaning, if these two angles are congruent, these two sides have to be congruent. And this is the converse. Well, this is the isosceles triangle theorem, and this is the converse of the isosceles triangle theorem. Both of them are true. Having said that both of them are true, we can also say that we can make a biconditional out of this. So what we're going to do is we'll take the original statement that says if you have an isosceles triangle, then the angles are congruent, the base angles are congruent. What we're going to write this as now is that with an isosceles triangle, so let's just say with an isosceles triangle, or this is hard to write. Why is this hard to write? If you have an isosceles triangle, if and only if you have an isosceles triangle, if and only if the base angles are congruent. That's what I want to say. You have an isosceles triangle if and only if the base angles are congruent. That's what I want to say. Because you don't want to say like, so this says, if there's an isosceles triangle, then the angles are congruent, then the base angles are congruent. You don't just want to take off the if and throw in an if and only if. You want to make it make sense. So, so if you have an isosceles triangle, then the base angles are congruent. So you have an isosceles triangle if and only if the angles are congruent. So maybe it would have helped if I wrote this out fully in the first place. Oh well, that's where laziness does not pay off. Cool. Now, along with these two theorems, the isosceles triangle theorem and the converse of the isosceles triangle theorem, we can do something else that's pretty cool. And this something else is, let's say that we have an isosceles triangle. And in this isosceles triangle, what we're going to do is we're going to bisect this angle up top. So I'm going to try and split that in half as best I can. So if I bisect, so this is an isosceles triangle, which means those two sides are the same, and I bisect the vertex angle. If I bisect the vertex angle, this line is called an angle bisector. Now, this angle bisector has a lot more properties. What it actually does is it actually bisects the base of the isosceles triangle. So we are bisecting this angle and bisecting the base. And this angle bisector bisects the base perpendicularly, which makes this angle bisector is also a perpendicular bisector. Now, we also know that the definition of an altitude is something that comes, a line or segment that comes from an angle and is perpendicular to the opposite side. Well, this follows that definition also. So this angle bisector that's also a perpendicular bisector is also an altitude. We also know that if we draw a line or segment from an angle to the midpoint of the opposite side, that's called a median. So we actually have an angle bisector, a perpendicular bisector, an altitude, and a median all at the same line. They're all the exact same thing. That's one special property of the angle bisector of an isosceles triangle. Now, this also works with equilateral triangles, that if this is the same as that, it's the same as that, and I bisect this angle, it splits this side in half, bisect that angle, and that's also perpendicular. So really, if you bisect the vertex angle or any vertex angle of an equilateral triangle or the vertex angle of an isosceles triangle, the angle bisector is also the perpendicular bisector, the altitude, and the median. And those are the theorems associated with the isosceles triangle, or with isosceles triangles.